Good afternoon, this is Schweitzer, and this is a quick little video on the mathematics of the car lab. We'll talk about it in class, but this is a quick little review in case you missed it. Our overall goal of the car lab is to determine the mass of a car or whatever item we're testing at this point. So our overall objective, determine the mass of a car. Okay. We'll do this in a few different ways, but essentially what we're going to do is the force that let's draw a picture of it. We're going to take a car and we'll have several students pushing the cars with force plates. Alright, so here we have our car, and of course if the car is just sitting there, then has balanced forces on it without anybody pushing on it. There's the force of gravity, and then there's force normal. Of course, if no one's pushing the car, then it just sits there. But if you take and you apply a forward force, let's go force of push or force from people, F sub P. We'll also inquire rolling friction in the reverse position. Assuming there's an unbalanced force in the forward direction, the force net, or I refer to as just adding the forces together, is equal to the force of push minus the force of friction. The friction has a reverse, a negative direction, seeing it's going to the left. Alright, now you should note that whatever force we apply to this thing, the difference in the force net, will cause the mass of the car to accelerate. Okay, so in this case, we have a little bit of math here. Let's break down the math here a little bit. I'm just going to take this piece because the difference in the forces will cause this object to accelerate at a certain amount based on its mass. You should note that if all of a sudden we're going to have some kids in this car, that if while we're pushing it, 3 or 4 kids jumped out of the car, the acceleration would start to increase because we have less mass. So a given amount of force will cause a certain amount of mass to accelerate. Basically Newton's law. Okay, let's break this down a little bit. We have force of the pushing minus the force of friction. The force of friction is the force normal times the coefficient of friction equals the mass of the object times the acceleration of the car. I'm going to put the acceleration of the car, AC. Okay, and then the force normal is equal to, because it's balanced at this point on a flat road, is the force of gravity, which equals the mass of the car times the gravity of the car times the coefficient of friction, so I'm just bringing these characters down, equals the mass of the car times acceleration of the car minus the force applied by people. Okay, and then at this point, I want to solve this. Everything at this point is just algebraic. Okay, so I'm going to subtract this guy over, or add it over. The force of the people is equal to the mass of the car times acceleration of the car plus the mass of the car times gravity times the coefficient of rolling friction of the car. I'm going to factor out the mass of the car times acceleration of the car plus the gravity times the coefficient of friction, and then equals the force applied by pressure of people. Okay, and then at this point I'm going to solve for the mass of the car. The mass of the car is equal to the force applied by the pressure divided by the acceleration of the car plus the gravity times the coefficient of friction. So in this case, we have essentially, when we're all done with this thing, our overall goal ultimately is to find the mass of the car. But to do that, we essentially will be determining the acceleration of the car, and then we'll eventually be finding the mass with the acceleration. So in this formula, we will be using a few different means. We'll be finding the acceleration of the car, plugging into this general formula. Everything else we'll be able to get from the data collected on lab day. Force applied by people. So let's just say, for example, we have the back end of this car, and and we have a few students pushing on this car. Okay, on the force plate, which happens to be a bathroom scale, it's measured in pounds. So let's say we push it and we want to attempt 30 pounds of pressure. How do I convert that over into newtons? Well, we're just going to get rid of pounds and go to kilograms. 1 pound is 2.2 kilograms. And then we will once we're in kilograms, to get to newtons, just multiply times 9.8, and that will give us our value, correlating value in a newton. So that's important if you're doing something here involved in this lab. Other things so that's the mathematics of this particular lab. Other things that are important, maybe, well, we'll highlight those in a different video. And we'll stop there. That's the mathematics, sort of an important part right there.